Hi everybody, it's time for the electric meter overload. Yes, here we got it. Going to do an overload test on these electric meters. That's a clamp strap, a environment, Landis&Gyr, 3 electric meters, and going to do a little surge test, or as if lighting struck, on a turtle. Those actually comes under the electric meters like that, and actually registers how much energy you have consumed and sends it back to the company. So you don't actually need to come in your house and take a look how much you have consumed. That's how it works. We're going to do a overcurrent and a surge test on all of these electric meters. And now I'm going to show you how I will do that. And yes, here's a schematic on how the electric meter looks like inside. Here you got the 3 individual phase meters. There's the 3 meters in the same. And they all got a voltage winding and a current winding. That's actually a current shunt in the new electric meters, but in the older one that's a coil. Both are coils in the old electric meter, but in the newer ones, newer versions, these are just transformers, potential transformers actually. There's 3 potential transformers inside it, not high voltage, just potential transformers, 230 volts to 23 volts. So that's how they are. So don't think I mean the potential transformers in the substation. And it's a current winding, or say current shunt in the new ones. Actually measures how many amps they're going through it, and it multiplies it by the voltage. So I'm going to do something called phantom loading. There got a high current transformer, or HCT, that pumps out 500 amps or more. Mine is not so big, it was 2.3 volts, but still it's pretty high current. That high current will go through the meter, nearly 300 amps. I want to try 300 amps on these meters. And they're going to add a 230 volts voltage on the voltage winding. So that will actually multiply the extreme high current 300 amps by the high voltage on 230 volts. I actually think it's 230 volts and the 300 amps, but it actually isn't. It's actually 2.3 volts through that and 230 volts across it. So actually lies for the meter. And I'm going to have that voltage applied to it, because that even runs the metering system and the display on the new electric meters. So I'm going to have that voltage applied on it, and I'm going to discharge a capacitor bank of 2 defibrillator capacitors in one coil like that, and see how well it can handle surges like a lightning strike in the power line. So they are surge tests, and when I do that I need to have a 5 kilovolt insulation on the feed on the 230 volt side. So it can be 2 MOTs connected with the secondaries together and the primaries separate. So I have 230 volts in, 2 kV out, 2 kV into the other transformer, and 230 volts out again. So that's how I'm going to do that, 2 MOTs, because they have very good isolation. So don't get that bloody spike in the house electric system and blow the computers and stuff like that. Don't want that. So let's take a look on the setup now. I'm going to take out the electric meters and I'm going to connect the MOTs and I'm going to show you how it will work. And here's the MOT setup. It's actually energized. The voltage comes in here from my variac. I'm actually going to connect that to the isolation transformer instead. That one. So I can have my variac connect up to the high current transformer. And as it goes on to 1 MOT, high voltage comes out from the secondary, goes back into the secondary, which now works as a primary, and energizes the secondary, which now is a primary, but now it's a secondary, but it's actually the primary, and yes, got voltage out. And just for safety, I put some boxes around it and I put the plastic on the top, so I just accidentally don't touch that high voltage. Now I just add that resistor bank there, so the current is much lower now, but still we got pretty good output. So let's connect the other wires to the variac, from the variac. And yes, now all the wires are connected. So I've got the 230 volts from the isolation transformer, MOTs. And here we got the variac. There's the live from the variac, here's the neutral. And here's another live from that beginning, that outlet there. So that's 240 volts, 230 volts. And now everything is out. Let's connect them up. Yes, that took a pretty long time to do. Nearly 1 hour to make that. But now it's done and it's time to blow the electric meters. So here we've got the setup. There with the feeding wire here, and that's a controller for the charging of the surge capacitor. I got the high current transformer, amp meter on it, short connections to the electric meter. It's a Lennis and Gurr one. And there's the wire for the high voltage, not high voltage, 230 volts. And there's the high voltage spike wires for a surge, 2 kV, 3 kV. Those into a contactor, and that's a transformer and the 2 capacitors. So yes, so let's blow the electric meter up. Camera gets a view on the amp meter and the underside of the electric meter, and this camera gives a close-up on just the electric meter. So I'm going to go inside now and crank the variac up. So yes, the electric meter didn't turn on. This is rated for 80 amps. And now the current is 610 amps. 620 amps. I wanted the electric meter to turn on. That stands on it 3 or 2 phases, so that's the problem. It's made, you need 2 phases, that means 400 volts for it to operate. So that's why it didn't turn on. But I'm going to crank it up, crank the variac up to the full range and see how long it takes to till it smokes. That kind of pretty good. 700 amps going to that. And now blow my fuse. So yes, that electric meter could handle that pretty well. So now I'm going to do the surge test and see what happens. So I'm going to charge a capacitor and discharge it into it. Yes, that was a little tick out of that. The next electric meter. Next electric meter. The cameras are differently set up. So I'm going to turn on the variac. Yes, and this one actually works. They start blinking away. It's getting 400 amps. And they're gonna crank the voltage up a bit more. Let's get more amps. So yes, this actually works. A bit more amps. .500 amps with 10,000 pulses per kilowatt hour, and this one is 500 pulses per kilowatt hour, and it smokes. It's actually a little smoke in it, as you can see. Some smoke on the top. So it actually don't. The other one was better. The Lens and Gur was better than this environment. And yes, it's actually going to smoke out. So I'm going to crank the current up a bit more. This now the current is up and it smokes a bit. 500 amps. So I'm going to turn off the variac. And now it's time for a surge test. And yes, that was our surge test. So next electric meter. So let's crank off the variac again. 21 amps. I got a current loss on that. So now I'm going to pop it with a surge. It's fine. So yes, that was a little pop, and it came off like that. Oh guys, I almost forgot the turtle. I need to pop the turtle as well. Yes, now the experiments are done. And this is actually a couple days later. The electricity meters just smelled awful. So now they don't smell that much. That's good, I left them outside. And now first we're going to take a look on the turtle. See what happened to it. Yes, you can see it, something has shattered. And that's actually the dropper capacitor. There's a little capacitive dropper inside it. That's actually the capacitor. Yes, now we have a closer look. You can see the capacitor that shattered away. That's actually its place. And nothing else looks so much damaged. Fuse looks a bit... Oh, that fuse is crushed. That fuse has exploded. So the fuse is gone and the capacitor as well. So this is what happened to the turtle. And of course I just did a surge on the input wires. Yes, I got the first electricity meter, I think. This was one, this Landis and Gurr. And this one actually didn't smoke so much. So here's inside. Not so much on the top lid. It's a little bit blackened here. Something has arced. And there you can see something. Yeah, so just there something has arced. That was a surge test. And this resistor here actually have some kind of hole in it to blow the piece off. It's definitely something happened with that resistor. Let's take a closer look on the circuit board. I'm going to take the shunt assembly off as well and show you both parts at the same time. Here we got the shunt assembly. Nothing looks damaged here. This was what that phase that I overloaded. As you can see, nothing has melted inside there. The shunt looks perfectly fine. So yes, not so much happened with this one. It's a little bang there as well. That little connection. The neutral one. So this one was a very good electricity meter. Sadly it didn't show anything on the display. It actually needs 400 volts to actually operate. There's little current meters here for this Landis and Gurr electricity meter. That actually survived the best one of the electricity meters. You can see there. There just shunts right through it. And we got a little fork here. Fork shaped thing. This actually measures the current somehow. Some magnetic field around it. It's got these little strange chips on it, on the circuit board. Look at that. Those actually registers the current on the magnetic field. The current that actually goes through it, that little shunt can go on that, and the camera is out of focus. And as it goes around the top side of the fork and creates a little magnetic field that those chips registers. That's a new way to actually, I didn't know that. So you can measure on that way. The Landis and Gurr one. Let's take a look on the second electricity meter. And this one was the next electricity meter I blowed up. This one was the Enerment, made in Finland, the Finnish one. There's a Chinese one as well, but this one is the Finnish one, 3-phase. And this one was the worst. Actually, nearly burned here. It came with some flames. So very good that it was sealed, so it wasn't enough oxygen to sustain a combustion inside it. Let's take the top off. Can I take a look? Here's the inside of it. As you can see, a lot of blackening. As you can see, something nearly burned here. And still it was the same current transformer that feed current into this one, and the same capacitor that is charged into a surge test. So I'm going to take all of this apart so you can see exactly what happened. Yes, this electricity meter smells awful. As you can see inside there, that's the third phase, shunt, second phase, and the first phase that I pulled some current into. It's absolutely melted. And look at that screw terminals. I could not even get my connection pin out of that. Yes, that thing is completely melted. So I should need to break the circuit board to get it off. Yes, let's do that. See what the surge test did. So let's now pull the circuit board back, and the surge actually shattered that resistor. There's pieces of that resistor everywhere. That we got a part of the resistor. That's some more parts of the resistor. That resistor is shattered. I don't know what happened with that move. And the rest of the circuit board just looks fine. And those capacitors actually was near the current transformer here. This one actually got current transformers. There's not shunts on this one. Because that current transformer actually melted away. Look at that. This is awful. So let's take a look on the next electricity meter. This one was the worst one yet. And here's the last electricity meter, the cam strap one. Let's take a closer look. And here's the cam strap meter. Actually the best quality meter I have, they say. It's made in Denmark. We'll take a look inside it. What happened? This one has a current shunt. So it's a high current test. Yes, something actually melted there, actually broke the connection to it. So that's good. It broke the connection. It was a high current, so it didn't burn or something. Not like that one. This was pretty good. So it broke the connection, so it was an open circuit. That's a whole, not damaged one. You can see how it looks like. Complete shunt, burnt off shunt. So I think that metal part in the middle here actually breaks when it gets too hot. And that's that one that I did a little surge test on. And yes, that one shattered the resistor. There's a resistor here that has shattered. So there's not so much any more damage here, so it's a little bit of blackening. And that blackening is around the trace. So yes, nothing happened with that chip. Just a resistor. So that's good, not so much happened with this one on the surge test. So this one was actually a very good electricity meter. It has a proper isolation as well. It's the heaviest electricity meter because it got these three transformers on it. And then they are potential transformers. 3 potential transformers on it. And I just got a little optocoupler there for the current feedback. So yes, this is of the electricity meter test. Thanks for watching.